code, right?
Morning, sir.
Please respond.
Sir,
In the last class, we have seen the
স্যার একটা
function codes.
কোশ্চেন ছিল স্যার।
Yes, yes.
স্যার লাস্ট ক্লাসে আপনি আমাদেরকে ফাংশনের স্যার কোড দেখাইছিলেন আপনি আমাদেরকে। তো স্যার আপনি
Yes.
দেখাইছিলেন যে ৩ টা পার্ট, পার্শিয়াল সলিউশন ছিল, একটা কমপ্লিট সলিউশন ছিল। তো স্যার কমপ্লিট সলিউশনটা স্যার আসলে কিভাবে লিখবো বা কোন স্টেপ কোথায়, কার পরে
Before the
কোনটা?
partial solution, you have to find the solution. Before that, you have to push onto the stack. Then you have to find the solution for the function that was the partial solution. Then after the partial solution, we have to find the solution for the pop from stack. Okay.
ওকে স্যার। স্যার আমি যদি একটু স্ক্রিনটা শেয়ার করে আপনাকে দেখাতাম একটু সুবিধা হইতো কি? একটু যদি দেখাতাম।
Okay, share your screen.
স্যার দেখা যাচ্ছে তো না স্যার?
Yes,
স্যার
I
এই
can
যে
see.
স্যার লেফট সাইডে কোশ্চেন দেখা যাচ্ছে। স্যার
Okay.
এই যে ২ টা যে লাইন দিছিলেন, স্যার এইটা কোন ক্ষেত্রে ইউজ করব আমরা? স্যার এটা কি আমরা স্ট্যাকের ক্ষেত্রে ইউজ করব নাকি স্যার আমরা এটা স্যার ফাংশনের ভিতরে
No,
কাজ
no,
করে
this is only for the inside of the function.
স্যার তাহলে স্ট্যাকের ক্ষেত্রে আমরা স্যার ওখানে কি ইউজ করব সেটা এটা একটু কোশ্চেন ছিল আমার। স্ট্যাকের ক্ষেত্রে।
For stack, we have to push how many declared variables are in the function. In the function, there are 4 declared variables that we
স্যার
have
এই
to.
যে এই ৪ টা।
Yes. No, 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 no.
স্যার
For
তাহলে
the
কি যে
fun.
স্যার এই যে GHIJ এই ৪ টা?
No, no, no.
স্যার এই যে
You are not
AB
getting the topic. Let
ওকে
me tell
স্যার,
you.
ওকে
We
স্যার।
have to find out first how many declared variables are in the function that is being called from the main function, not the main function. Okay.
ওকে স্যার ডিক্লেয়ার্ড ওকে।
How many declared variables? So how
স্যার
many
4
declared variables?
FABC
4. That is why we are actually pushing 4 and popping 4.
স্যার তাহলে স্যার এই যে এই ৪ টা লাইন, এই ৫ টা লাইন।
Yes, for push and for pop. That is due to that there is 4 declared variables in the function.
জি স্যার। স্যার তাহলে স্যার ওভারঅল স্যার আমার এই প্রবলেমের সলিউশন স্যার এই যে এই কয়টা লাইন, তাই তো?
Actually, you have stopped your screen share, but
স্যার
uh,
মেবি নেটওয়ার্ক প্রবলেম।
okay, no problem. So your solution should be first push the amount of registers we need to push is we have to find out from the function, given function. If there is 4 declared variable, then we have to push 4. Then we have to do the work for the function. Then we have to pop. Then we have to write just JR register array to end the function code. Okay.
ওকে স্যার।
Okay. So let me share my screen. So today we are actually going to learn about machine code conversion. Okay. So up to now we have seen C code being converted to MIPS code. Now we are going to see how we can convert this MIPS code to machine code or binary. Like in the first class, we have seen that our actually before midterm goal is to know how we can actually convert these high level codes to low level machine or binary language codes. To do that, we know we have to go through a intermediate level, that is assembly language, mid-level language, and this is MIPS assembly. So we know how to convert C code to MIPS. Now we have to know how we can convert this MIPS code, these instructions, to binary information. Okay, so today we are going to see that. To do that, we are going to take help of these two tables, this one and this one. The necessary information that will be required from this table will be given in the question, attached with the question. Okay, so you need not to memorize anything in here of these tables. You need not to memorize anything in here. You just have to maybe remember the number in here from this table. It is easier. I will let you know how it is easier to remember the numbers of the registers, but you don't have to remember anything from this table. This table will be provided along with the question. You are going to see this table and fill up the necessary information required to convert instruction or mixed codes to binary information or machine code. So they have divided actually the instruction, all the instruction in three types to convert this to machine code. Okay, so these instructions are divided into three types. R type, J type. R type are the normal ones, so those instructions there is some different instruction will be there in each of the types. Maybe there is some different instruction, but for R type, most of the instruction has three operands. For I type, most of the instruction has two operand or two register and a constant value or label or address, something like that. Okay, like in load word, there is a constant value for offset, and I or I there will be a constant value, and same for add I, and for B key BNE there is a label or address given. Okay, so these are for I type, and J type has unconditional jump instructions in it. And out of these three unconditional instructions that we know, J, JR, and JL, these two are included in J type, and JR is in the R type. Okay, so we have to know, this is very important for us, which one is which type. Even if we don't know, uh, we can look at this table and we will be able to know. R type is denoted with R, I type is with I, and J type is with J. Okay, this is a table. Let me show you. Okay, this table has many columns in it. Okay, first column is for the name of the instruction, then type of that instruction, format R type or I type or J type. Then there is many information given. Out of this many information, we need only two from this table, and that two will be provided along with the question in the midterm. Okay, in the midterm question, we are going to provide that. Uh, so
স্যার আমরা
these
কি
are the
এই
two
টপিকে
information
ক্লাসটা
that
দিব
is
না?
going to be provided to you. You need not to remember. What? Yes, yes, yes.
স্যার আমরা কি স্যার তাহলে সিটিতে কি আমাদের এই টেবিল দেওয়া থাকবে না?
That
আপনি যে
table
বললেন
is
শুধু মিডল
already
থাকবে।
on your hands. I will
ওকে
actually attach it with the question in the midterm, but I have to
জি
decide
স্যার।
whether we are going to take cities on these topics or not. If cities have these topics included, this machine conversion, then I have to give it in the question. If not included, if cities are maybe for C code to MIPS conversion or for the rest of the part that we are going to see after this topic. So if this is included in the city, we are going to attach it, because as we do not know the syllabus of the city, I'm not going to talk about it. Okay. So these
জি
are the
স্যার।
two columns that will be attached with this table for your information. This OP and FUNCT. This OP is opcode or operation code, and this FUNCT is function code. Okay, these two information you never need to remember. You are going to get this from the table, and rest of the information you have to find. You have to find. Okay, and one thing you must have to memorize, that is these things, it will not be provided along with the question. You have to remember the registers numbers. Okay, what are these? The zero, $0 register has a number. As we know, in MIPS we have 32 registers, so the registers are numbered from 0 to 31. Like in this table you can see registers are being numbered from 0 to 31. Some missing registers are here as well. We need not to worry about those. As you can see, there is 0 number register and there is 31 number registered. So we have to remember about few registers. What is the value of 0 register? The register number for 0 register is 0. $V0 V1 is 2 and 3, the return value registers. And after that, the argument registers are from 4 to 7. Then the temporary registers, 8 temporary registers from 8 to 15. So what you have to remember is, remember everything is multiplied by 2 in the left side, except for the 0. 0 is 0, then 2, 4, 8, 16. 2 multiplied by 2, 4 multiplied by 2, 8 multiplied by 16. That is why you have to remember. You have to remember the series. After the 0 register, it is return value, argument, temporary set in this order. And if you remember this, you will always remember that return value register V0 is 2. So V0, V1 should be 3. A0 is 4. Then A1 should be 3. A2 should be, sorry, A1 should be 5. A2 should be 6. A3 should be 7. And if you remember T0 it is temporary register T1 should be 9, T2 should be 10. In this way, T7 should be 15. If S0 is actually 16, then S1 should be 17 in this way. So I guess you can remember these register numbers. In case you do not find the trick easier, you can use any method to remember this register number that you have to remember. Okay. And there are two more temporary, as temporary register is actually 10 temporary registers available, T8, T9, register number 24, 25. Then you have to remember the register numbers of these two registers only. Stack pointer, that is 29, and register RA, that is 31. So we may need not these register numbers if the frame pointer, which is 30, GPU, which is 28. So I guess you have to remember in any way you can remember to remember this table. Okay, we are going to need this. For now, just think about two instructions, two register numbers in here. T0 is 8, S0 is 16, and 0 is 0, register RA is 31. This for information, if you remember, that will be enough for today's class. 0 is 0, register RA is the last register, that is 31st number register. T0 is 8, S0 is 16. That is what you need to remember. Okay, now coming back to the mixed fields, there are three types of instructions available. So they have divided this instruction into three types so that they can find the machine code easily. So for machine code, for each of the type is separate from each other. That is why they have divided these instructions in three types. Okay, so we are going to see some instruction being converted to mixed code so that we can understand what are these types are. So this is R type. Up to now, before I show you this slide, let me know you are hearing me loud and clear. Please respond.
Yes, sir.
Okay, thank you. Okay, thank you. Now this is R type instructions. Okay, R type instructions in the MIPS field. This is MIPS field. R type, I type, J type. R type instruction has 6 subfields. 1, 2, 3, 4, 5, 6. And these 6 subfields has their names. OP, RS, RT, RD, shamed function code. OP is opcode or operation code. Opcode or operation code that will be given in the table. Like for add instruction, the let me show you. For add instruction, the opcode is 0. Can you see that? Please let me know. For okay,
Yes, sir.
okay. The operation code will be given in the table. You don't have to memorize it. Actually, when you are going to convert this instruction to binary, actually it will be easier for you to remember. You need not to memorize, but if you practice more, it will be easier for you to remember. But you need not to memorize these two things in here. So RS, what is RS? We know in R type instruction, most of them have three operands, three registers, and those three registers type instruction has one destination of two source. So RS is first source register or first source operand, whatever we say. RT is second source register or second source operand. RD is the destination register, RD destination register. And shamt is actually amount, shift amount as shift left logical or shift right logical. These two are part of the R type. So there is this shamt. And then the function code. Function code. And what is that function code? You are going to find it from the table. Can you please tell me what is the function code for AND instruction? This is function code in here, this column. And what is the function code for AND?
36.
36. So can you find opcode and function code if the table is given for any instruction? Can you find that for any instruction?
Yes, sir.
স্যার কি
Okay,
কোড
so
আরেকবার
now we are
বলতেন
going
স্যার বুঝি নাই
opcode, opcode and function code. These two are given in the table. You need not to memorize these things. We are going to find it from the table. Okay, because in the R type field, machine meets field, we have seen there are 6 subfields, and for each of them, we have to find out the value except for these two. Because opcode and function code will be given in the table, we have to use the table to find the values of this. And for source register 1, source register 2, destination register, and shift command, we are going to find it from the instruction, given instruction. Okay, I'm going to just move on to the next slide. Not in here, actually, in the Word file. So, for R type, we are first going to convert this add instruction. Remember, they will only give add as the instruction and necessary register along with it. Okay, so it is add S0 S1 T2. Add S0 S1 T2 is the instruction. Okay, I'm going to copy this in here so that it is easier for you to look. Okay, okay. So this is the add instruction. This is the mix field of code RS, RT, RD, shift amount, function code. I'm going to repeat again. This is operation code. This is function code. We are going to find it from the table. Source register 1, source register 2, destination register. If there is any shift amount, we are going to use it in here. So for R type instructions, we are going to need to fill every information in the subfield. Then we are going to convert this information to binaries in this amount of bits, as function code is 6 bits, opcode is 6 bits, and the rest are of 5 bits. Remember, whatever the type it is, if we are going to convert any instruction to binary information, it will be combined of 32 bits. If you add this all subfields bit numbers, 6 plus 5 plus 5 plus 5 plus 5 plus 6, it will be 32 bits. Like 6 plus 6 is 12 and 4 into 5 is 20. So 20 plus 6, 12 is 32 bits. So whatever the type it is, the binary information will be in 32 bits. Okay, so the first we are going to convert this add instruction to me. To do that, we have to know that there are 6 subfields and we have to know that add is from R type. How we are going to know? We have to remember these sets in here. For R type, this is the set, I type, this is the set, and J type, this is J and JAL. So first thing we need to know, add instruction is of which type. So the moment we know it is of R type, we are going to draw these 6 columns in here. OP, RS, RT, RD, SHAM function code. Below that, we need 6 more columns as well. Now we need to fill up these columns. Okay. Okay. Now we need to fill up this column. As in there is nothing in here. Do not worry about these things. We just need to fill up these columns below these column names. OP, RS, RT, RD, SHAM function code. Up to now, everything is clear. How we are going to convert this add instruction to machine code? Please respond. Everything is clear. Please respond.
yes sir
Okay, okay. So, can you please tell me, looking at the table, what is the opcode and function code for this add instruction? I'm going to show you the table. This is the table. Just let me know what is the opcode and function code for add instruction.
0 and 32, sir.
0 and 32. This is the 0 opcode and 32 is the function code. Okay, so I'm moving just out of that slide. So 0 and 32. Easy. You can find this easily, right? This is easy.
Yes, sir.
Okay, now can you please tell me, out of these 3 registers, which one is destination, which one is source 1, which one is source 2? Looking at these 3 registers, which
sir
one is the
dollar is S0 destination
so it should be $S0 in here, right?
जी sir
And which one should be the source one?
sir source one dollar S1
$S1, then source 2,
sir temporary 2 T2
$T2. Now, as we have uh, given the registers names in here, we have to give the decimal values of all these columns in here as well. Okay, we are going to give the decimal values of all these columns in here as well. So 0 has decimal value of 0. What is the decimal value of this 32? It should be 32. And what is the decimal value of this S1? Do you remember T0 is 8, S1, S0 is 16 from the table? T0 is 8, S0 is 16. You remember that?
Yes, sir.
Okay. So if T0 is 8 and S0 is 16, then what should be the value for S1?
17, sir.
17. S0 is 16. If T0 is 8, what should be the value for T2?
10,
So
sir.
10.
10. As we do not have any shift amount in here, we do not have any shift amount in this add instruction, we are going to give a cross sign or X in it. Cross sign. Okay. So no decimal values for it, just a cross sign. Okay. Now, as we have converted these register numbers onto decimal values in here, we have to now convert these decimal values onto binary. And we do know that in R type, function code and opcode are of 6 bits, and the rest of them are of 5 bits. Okay. So what we have to do, I'm going to convert this all information in binary. Okay. So just do not worry about the in between step. This is nothing actually. These are the three things we needed to do. Then we have to convert this latest information into binary. Now this function code and opcode will be in 6 bits. I'm going to convert these two first. Then I'm going to convert these four, which are in 5 bits. Now can you please tell me 32 in 6 bits? How can we write 32 in 6 bits? 32, 16, 8, 4, 2, 1. 32 in 6 bits. Is it clear? If you cannot just convert 32 in binary in 6 bits, just do that. Use your calculator. If you just cannot convert it directly, uh, go to programmer. In decimal, I'm giving 32. This is the binary of it in 6 bits. 1, 2, 3, 4 zeros, 5 zeros, then a 1. So this is the 6-bit binary of 32 bits. Is it clear? Why we are actually writing it in 6 bit? Is it clear to all of you?
Yes, sir.
Because format says opcode and function code should be in 6 bits and the rest should be in 5 bits. So it is 32. Now this 0, we have to convert this 0 in 6 bits in binary. So can you please tell me how many zeros we are going to write in here?
6.
1, 2, 3, 4, 5, 6, 5. Because the binary of 0 should be written in 6 bits in here. Now again, now we have to convert this 4 but in 5 bits. So it is x, we are not going to convert this, we are going to keep this like this. This is x, this is no conversion for this one. And for 17, 10, 16, we are going to convert these to binaries. So for 17, what is the binary? 16,
10001,
remember,
sir.
16, 8, 4, 2, 1, right? And this is in 5 bits, so this is correct, 17. 10 is actually 1010. This can be written in 4 bits, but we have to make sure it is of 5 bits, so we are going to add a 0 at the first or left. Is it clear?
Yes, sir.
And this is 16, 1, 1, 2, 3, 4. So can we convert this add instruction to this machine code now? Is it easier?
Yes, sir.
Okay, so looking at this slide, if the instruction name is sub, I have already uploaded that slide on the LMS. You can download if you want. if the instruction name is sub, can you guys please name what are the changes will be done in here in this part? What are the changes will be done in here or in this part or in this part? What are the changes will be done? If this instruction is sub, what are the changes we are going to do?
Sir, function code maybe 34.
I wanted this answer from you that we are only going to change the opcode and function code and nothing else in between, right? Because for sub, this is destination, this is source 1, this is source 2, and the if the registers numbers are same, these four will be same. Only we have to change opcode and function code. And if we see the table, opcode is same for the sub. Let me show you. Opcode is same for sub 0. Only the function code is different from the function code of add, that is 34. So is it clear how we can convert this sub instruction into machine code? Please respond.
Clear, sir.
Okay, fine. So if this is clear, then I'm going to give you some instruction. SRL, okay, SRL and GRRL, okay. So please do convert this to instruction. I'm going to give you in the chat box. Not in the chat box actually. Okay, okay. Let me delete all these lines in here. Do convert this one first, okay? Write down opcode RSRT. I actually accept this that you will be able to convert decimal to binary. So in the class, when I'm going to ask you to solve any instruction, you need not to convert to binary. I hope all of you can convert using calculator or whatever you prefer these decimal values into exact number of binary bits, right? Can you convert this? Please respond.
Yes, sir.
So I guess there will be no problem in that because you can use your calculator if you need. So now what I'm going to ask you is that you are going to fill every information in the opcode rs rt rd sham function code in decimal and the number of registers. So you're going to write the name of the register first. Then so you're going to find two columns for me for every instruction so that I can see you are doing it perfectly. For that you need help of two tables. One is the table for this one where you can find the opcode function code. Another table, if you remember, T0 is 8, S0 is 16, 0 is 0, and RA is 31. I guess for today's class that is enough. Okay, so do find the solution in here. T0 is 8, S0 is 16, and that table I'm going to actually show you. Wait, I'm going to share that table only. Okay, and I'm going to give this SLL instruction in the chat box. We need to find the solution. I've given the SLL instruction in the chat box, and I'm going to share only the slide. Okay, do find the values directly. Okay, I have shared the table with you. See the table and please do find the solution for SLL instruction, which is of actually R type. And let me know your answers in the chat box so that I can check whether you are correct or not. Okay, Afanur, let me check your solution. Afanur, your solution is not correct. Yeah, Afanur, your solution is not correct. Please try to correct that. Sumaya Yasmin, you want to say something? You raised your
স্যার
hand.
ভুলে অন হয়ে গেছিল স্যার।
Okay, okay. So,
Sir, I also did it like half an hour. Same.
but then your one is not correct as well. Try if you cannot find the correct solution, I will give you the correct solution. Do not worry about it.
Okay, sir.
স্যার 20 এখানে কি এক্স হবে স্যার? 20 তো কনস্ট্যান্ট নাম্বার, সেজন্য মানে ক্রস দিব।
No, no, no. I'm going to come back to you, but most of you have to try it first. Okay, take five more minutes, then I'm going to give you the solution. Please try. Until then, whatever you can, then I'm going to give you the solution.
স্যার কিভাবে দিব? প্যাটার্নটা আরেকবার দেখাইলে ভালো হইতো স্যার, টেবিলটা।
Okay, okay, okay. I'm going to stop the screen share and share my interest. I'm going to forward the solution. I wanted to give you 5 minutes. but that is okay. So most of you have find something correctly. That it. Can you see the screen first? Let me know from this. Can you see
Yes,
the
sir.
screen?
Yes, sir.
So all of you have done these things perfectly, I guess. Opcode and function code is 0. That is, you guys know, right? From the table.
Yes, sir.
Now, what is the destination register in here?
Sir, T0.
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 Then it should be dollar T0 in here. Now I'm going to replace this T0 with the decimal later. And what is the source registers are in here? Source 1, source 2. You tell me. This is
Yes,
source
sir.
1, right?
Source 1
$1
S3. Yes, sir.
This is okay. Okay. Why you guys are so confused? This is dollar S3 actually. Source 2.
Sir,
Source
20.
2 maybe X হবে
Not
sir.
sure.
Is there any source register available
No, sir.
anymore? No. You guys are saying this is 20, but 20, how can this be a source register? 20 is a
Yes, sir.
constant value. And this is the value we want to shift this S3 and save the value onto T0 register. We want to shift S3 20 times and
Oh,
save the value onto T0 register. This is shift amount 20. And then this is empty. This is empty. We do not have anything for that. So what is the register number for this S3?
So 19.
19.
16, 17, 18, 19. Very good. And T0 is 8. We all know. It is 8. So this should be our solution. Now we need to just convert this to 32-bit binary information. Is it clear?
Yes, sir. Understand.
Okay, fine. I guess so. Everyone has the solution of this. Can I give this solution in the chat box? Just wait. Yes, I can. This is the solution.
Sir, and the 20 is for shift, right?
Yes, yes. Shift amount. So one more instruction. Try to find this one. Sorry. Okay, so this one is in here. So I just need to delete all the values in here. Oh, and the value of JR register on it. And do let me know when you are done. This is the instruction. I'm going to drop this instruction name in the chat box. I'm going to share only a slide with the table so that you can. And you guys know the register number for RA is 31, right? You know that. So try to find the solution for JRR, and it is of R type. Remember, it is of R type. Try to understand the solution. Just don't try to write something you don't understand. Okay. Try to give your solution in the chat box so that I can see. Okay, Tariquজ্জামান Tuhin is actually correct. Afanur Rahman is not correct. Afanur Rahman, you are using zero, but zero means in the source register zero, it means zero in the second source, zero number register in the destination register, because this zero denotes to a register number that is register zero. So you cannot write down zero in the RT and RD section like in the slides. So do not follow the slides, follow my lecture. And in the shift amount, you cannot write zero even. Okay, you have to put cross because we do not even want to shift. Why we are going to shift zero times, right? So there is that, and Syed Ishtiaq Rahman, very good, very good, and Fadia Jogun, these are wonderful. Okay, so what I have seen in here that you guys perfectly got this one, that register RA is the source register. It is not the destination register. I have seen students confusing between these two things, that what register RA will be. Will it be a destination or source? So it cannot be a destination register, right? It has to be a source register. So Afanur Rahman, correct your solution. Rest of them is pretty correct. I'm happy with your solutions. If anyone is confused with their solution in the chat box, do let me know. Okay, so I'm going to stop the screen share and share my entire screen. For those who are yet to find the solution, do I have to show you the solution for this? Because they have already given the solution in the chat box. Opcode is 0, function code is 8. Let me give you the solution. Opcode is 0, function code is 8. This is a register RA. There is no second source register, no destination, no system.
স্যার আরে কিভাবে সোর্স রেজিস্টার হচ্ছে স্যার?
Is it destination? You tell me. Are we going to write anything in this register after executing this instruction? Like
না স্যার।
executing this instruction, we are going to write something onto T0. After executing this instruction, we are going to write something onto S0. After executing this instruction, we are not going to write anything in it. So this cannot be a destination. This has to be a source. Source registers means we need to read this register's value and do something. Like we need to read this register's value and shift. We need to read this register value and this register's value and then sub. This is what source registers are of, because if we have to read the register, then it is source. Now we are going to read the address of this register and we are going to jump return. So this is source in here, and this should be replaced by 31, and 31 is the register number for this register RA. So this is it, the solution. I'm not going to drop this in the chat box because all of them have given their solutions in the chat box. You can see that if you want. So I'm going to go to the next topic. Just give me some time. Okay, we are perfect. So we have seen R-type instructions like J are the different ones, SLL. So we can find for SLT as well, NOR, OR, and sub. You guys need to practice all of this at home. Now I'm going to show you I-type. Remember, in I-type there are two registers and a constant value, or a label or address. Normally there will be no label. We cannot convert label to binary, but we can convert address to binary. So we are going to see binaries as well for addresses given, not for the labels. Okay, so I'm going to show you. As we have seen for R type, there were 6 subfields. Now I'm going to show you for I type how many subfields are in there. So up to now everything is clear. Please respond. Up to now for R type. For R types everything is clear.
Yes, sir.
Okay, so for R type everything is clear. You need to look at the I type instruction. For I type instruction, there is 4 subfields, not 6 now. Opcode RSRT. Remember, there is no destination RD in here. So all these sources are in here. Maybe there is destination in the instruction, but we are going to use RSRT. How? I'm going to let you know. So there is opcode RSRT, and we do know opcode is of 6 bits, RS 5 bits, RT 5 bits, and there is that constant or address. As I have said it earlier, these instructions have 2 source and then constant or 2 register and constant or address. So this is the thing in here, constant or address. So this is it for I type. For I type, this is the format: opcode, rs, rt, constant or address. Now if this is 6 bits, this is 5, this is 5. So this 3 makes 6 plus 5 plus 5. So 16 bits. As we know, our instructions will be converted into 32 bits information combined together. So can you please tell me this constant or address will be written in how many bits?
16, sir.
16 bits, right? So this is that 16 bits, okay? So this is that constant or address. The first instruction we are going to convert in here is store word, okay? Store word $S020 S1. Now there is that important thing in here, okay? Let me do, okay, okay. Why can I not? Okay, I can drag it. Okay, okay, perfect. So what is that? Here, as you can see, in this store word instruction, what we are trying to do, we are actually adding these two values, trying to find a location.
ছুটি, সবাই চলে যাও।
Hello everyone, can you hear me?
Yes, sir.
Okay, I was disconnected due to no Wi-Fi connection, so I had to switch to mobile network. So let me share my screen again. Just wait. Can you see the screen? So constant or address is of 16 bits. So this is the first instruction we are going to convert for this I type load word S020 S1. So do we understand this load word instruction? Please respond. Uh, do we understand this load word instruction? Can you hear
স্যার
me?
আরেকবার বলেন।
Do we understand this load word instruction, how it works?
Yes, sir.
Because this will add this offset with the base address of this array to find a location of the index of the array. 5 into 4, this is actually A5. Let me give the comment. For example, we are going to store, sorry, this is S0. If the base address of array A is in $S0, this should be our conversion, right? This should be our conversion. Please respond. Assume this is temporary. So this should be our conversion, right? Is it clear?
Yes, sir.
And if this is clear, this T0 is looking like a destination register in here in this instruction, right? Please
Yes,
respond.
sir.
Yes, sir.
there is no RD available, then in which source register RS and RT you are going to uh, use T0, RS or RT. So as there is no destination in the format of this I-type memory field, so we are going to use the registers in cross connection. T0 will go to the second source register, S1 will go to the first source register in this cross connection. So is it visible, the cross connections? Please
Yes, sir.
respond. So for load word, if we look at the table, if we look at the table in here, for load word sorry, for load word instruction, the opcode is 35. There is no function code available as there is no function code in the I-type format available. So for load word, the opcode is 35. Okay. So if the opcode is 35, then we can use 35 for the load word instruction. And if we have to use these registers in cross connection, this T0 will be in here in $T0. This $S1 will be here in this $S1. And this 20 will be this constant or address here. So is it clear how we can convert these I-type instructions into decimal values?
Yes, sir.
Now for S1 it is 17, it is 8, so we can convert this instruction to actually binary, right? Can you please tell me in how many bits you are going to convert this 20 into binary?
16.
16 bits, right? So
5
this is
bits.
it. No, 16 bits, 0 to 15. Please see this one. We have to use 16 bits for constant or address, not 5. Clear now to everyone why it is 16 bits? This 20 or whatever it is, it has to be in 16 bits, yes. So is it clear? Please respond.
Yes, sir.
Yes, sir.
Okay, so can you do this for me? I'm going to drop this in the chat box. To find the solution of this instruction, okay? And let me know in the chat box. I'm going to give you a few minutes to all of you. I'm going to stop the screen share. I'm going to let you know what is the value of actually opcode for and I. Opcode for and I is actually 12, okay? I'm going to give you that opcode as well. Just find me the solution. After you find the solution, I'm going to show you another instruction for I type, then I'm going to move to the J type. Remember, for and I type, you have to use the instruction in cross format. And the format is OP, RS, RT, and constant or address. PM Hossain Sarkar 12, 17, 16, 223. Very good. Very good. Others, do let me your solution. Do let me know in the chat box. Others having any problem finding that solution? Anyone facing any difficulties to find the solution of this problem? Say this Rahman. Very good. Okay, you are done. Very good. Very good. Say this Rahman. Okay, so I'm going to share my screen and actually show you the solution. They are saying 12, 17, 16, 223. So this is 12, 17, 16, 223. Can you see?
Yes, sir.
And this is the binary of 12, 17, 12 in 6 bits, 17 in 5 bits, 16 in 5 bits, and this 223 in 20 bits. Sorry, 16 bits. 16 bits. Okay. 0 to 15, 16 bits. Okay, so this is it. I'm now going to show you the solution of this one. I-type branch or not equal. You have to know about this. Okay. So this should be S2 should be in here 18, S1 should be here in 17 RT. This 100 should have been here, but for B and E and BEQ there are this address, not the constant. If there is that address in place of the constant, if there is any address given in any instruction, we have to divide it by 4 and keep it in here. We have to divide the address by 4 and keep it in here. Is it clear? Please respond. Hello, everyone.
Yes, sir.
Okay. So this is BNE for BQ. If there is any address, we are going to divide it by 4. This is the rule. Why it is the rule, I'm going to explain later. Now I'm going to move to the jump and the J type instruction. Now for J type, there are two subfields only: opcode and the address. Opcode and the address. If the opcode is in 6 bits, to make it 32 bit, we have to write down the address in 26 bits, right? Please respond. Please respond.
Yes, sir.
Okay, so address will be in 26 bits. If this is the instruction J 2000, then for J opcode is 2 from the table, the address should be 2000 divided by 4, which is 500. We have to write down the binary of 500 in 26 bits. If the address is 10,000, jump and link 10,000, this is opcode for jump and link, and we have to divide this 10,000 by 4, and this is 2500 in this address section by dividing by this 10,000 by 4. I guess JTAG is much more easier than the other two types. So is it clear how we can write down the binary information of converted mix code? Please respond.
Yes, sir. Clear.
Okay, if this is clear now, I'm going to explain why we are actually dividing it by 4. This is my question. Why we divide by 4? So can you let me know? Up to now, everything is clear? I'm going to stop the screen share only. Wait only to the Word file. Can you see the Word file? Let me know. You can see
Yes,
the Word
sir.
file?
Yes,
Okay,
sir.
so we have a question. We have a question. Why we are actually dividing this address like it is 2004? We are dividing it by 4. This is 501, and there will be no such address that we cannot multiply by 4. Multiple of 4 actually. So if we divide by 4, there will be no decimal points. That is one more confusion that you might have. So there will be never be such address like 2003 or 2 or 1. It will be either 2000 or 2004. Okay, so this is it. So why we actually divide it by 4, we are going to know. What is the value of 1 in power of 2? 2 to the power 1 minus 1. 2 to the power 1 is 2, and minus 1, it makes it 1. So in 1 bit, the maximum value we can get is a single binary 1, or we can say 2 to the power 1 minus 1. In 2 bits, in 2 bits, what is the maximum value we get? 2 ones, or in decimal 2 to the power 2 minus 1. Okay, so if I ask you to find a value, the max value in n bits, your answer should be n1, sorry, one answer is n1 and the other answer is 2 to the power n minus 1. This value is in binary, this value is in decimal. So these are the maximum value in n bits. So if I say what will be the maximum value in 16 bits in binary, what should be your answer? 16 ones, right? Please respond.
Yes, sir.
What will be the maximum value in 16 bits? 16 ones, and in decimal it is 2 to the power 16 minus 1, right?
Yes, sir.
So in here we know for the I type we have 16 bits only, right? For I type we have 16 bits only, right? Please respond.
Yes, sir. 16 bits.
Whatever the maximum value we can get in 16 bits. In binary it is 16 1 and in decimal it is 2 to the power 16 minus 1, right?
Yes, sir.
So I assume this 2 to the power 16 minus 1 is x. So can we say in 16 bit the maximum value we get it is x?
Yes, sir.
Okay. So if there is that 4x plus 4, if that is the value of the address we need to jump, 4x plus 4. In other words, if we take the commons in here, we can say 4 into x plus 1. So if this is the address we need to jump, and if we divide this address by 4, whenever this is the address given in here, we divide this by 4 and store it in here, right? Please respond.
Yes, sir.
So if we divide this address by 4, what will be this value? This x plus 1, right? Please respond.
Yes, sir.
In 16 bit, if we can maximum write x, can we write down this address in binary x plus 1? As you have said, in 16 bit, we can maximum write up to 16 ones, right? In 16
sir.
bits, we can maximum write up to 16 ones. And this 16 ones is equal to x. If this 16 ones is equal to x, and if there is some address that if we divide that address by 4, this is like it, then can we write down this address in binary in here in 16 bits? Is it possible? No. Why? Let me tell you one more thing. In 2 bits, what maximum we can write? 2 ones, 3, decimal 3, right? In 2 bits. Please respond.
Yes, sir.
If I ask you to write 4 in 2 bits, can you write down it in binary in 2 bits?
No, sir.
So if this is the maximum 3 which we can write in 2 bits, 3 plus 1, can we write down it in binary in 2 bits? Is it possible?
Yes, sir.
No.
No,
How
sir.
can it be possible? How can we write 4 in binary in 2 bits?
Oh, sir. No, sir.
Minimum 3 bits, sir.
So if this
Maximum.
3 is x maximum in 2 bits, we can never write x plus 1 in any kinds of bits, right? So if this x is maximum in 16 bits, we cannot write x plus 1 in 16 bits, right? Please respond.
Yes, sir.
So what if the address is actually this? Then can we just not convert it to binary? Actually we cannot. Okay, but we are actually dividing it by 4. 4, right? Had we not divided it by 4, and directly written this address in here, this would have been this address, right? Had we not divided by 4, directly write the address, whatever is in the instruction, not dividing by 4, we would have written this address in here, right? Please
Yes,
respond.
sir.
Yes.
So even if that address is 4 times less, 4 times less than that, remember, if this is the address, what will be 4 times less than this address? This one, only this one. Then we wouldn't have still managed to store it in here, right? So what
Yes, sir.
maximum we could have stored in this address if we hadn't divided by 4? If we hadn't divided by 4, maximum we could afford is this x, right? Right? Please respond.
Yes, sir.
As we are dividing by 4, now we can maximum take 4 times of that address. So by dividing by 4, we can actually take 4 times more addresses in this instruction, right?
Yes, sir.
So now is it clear why we are actually dividing by 4? To actually access more address. Actually 4 times more address. Is it clear?
Yes, sir.
Okay, so if this is perfectly clear to
Sir,
all of
is
you.
this theory needed for our class test or
Yes,
midterm?
obviously. Why not needed? I'm explaining it in here. So it is obviously needed.
Okay, sir.
So this is, I'm just writing it to 4. Okay, this is it. So I'm going to stop the screen share. I'm not going to show anything in here. Is there any confusion in today's lecture part?
Sir, there are 3 extra rows in the table. You didn't explain those rows.
In that word file you are saying?
Yes,
Talking
sir.
about?
What file? Yes, sir.
Okay, just wait. What are those rows? What are those? Which table?
Yes,
Which
sir.
table you are talking? This
This,
table?
sir. The first table. This, sir. Okay.
You
Sir, third
need
row.
to know. No. You just need to know this one
Okay.
and
And
this
the
one.
last one.
Yes.
Okay, sir.
Okay, is it clear?
Okay, sir.
Any confusion in today's lecture?
No, sir.
Okay. So I'm going to stop the recording and take the attendance, and that will be all.